Hey everyone, my name is Aziz. I'm one of the core team members of StellaSwap. This was actually supposed to be our CTO coming, but unfortunately because of visa issues, I'm taking over his spot. So I'm going to give you sort of like a high level in terms of our three main sort of like innovations that we did, on a technical overview of that, right? So before that, just going to go on a high level what we've done, the traction. We're the only DEX on Polkadot that has surpassed over $1 billion in trade volume, the most used DEX. So we're based actually on Moonbeam Network, right, which is an EVM parachain on Polkadot. Over there, 90% of the trade volume happens on StellaSwap. So yeah, 60% of trade volume on Polkadot happens on StellaSwap. So we're really proud of the fact that we're basically the natural shelling point of trade within Polkadot. What we'll cover in this sort of like snippet, right, is going to be three main things. Our router, liquid staking, and our Merkle rewarder. So first thing, right, our router, efficient trading. Now, we're made up of three AMMs. So we have a normal AMM, right? XY equals KAMM, constant product. We have a stable AMM for correlated assets. And we launched concentrated liquidity V3 AMM powered by Algebra at the start of last year, right? So this presents an issue. Each AMM in itself is a siloed liquidity, right? So the main question that we have to ask ourselves, right, is how do we unite all the liquidity within the AMM that we have under the hood, right? And for that to happen, we need to build our own hybrid route, as in universal router, that sort of like ensures that we can tap on the liquidity depth of each of the AMM that we have. Obviously, each AMM has its own characteristics, and that's why we sort of like we launched those AMMs under StellaSwap. So we made our own routing. So what does the router do, right? So whenever a user inputs, for example, he wants to buy DOT using a stable coin, right? That's his input, right? And our router will automatically look across each AMM. Each sort of like a row is a different AMM, and they're just going to cross-compare sort of like the most efficient way to get the DOT, which is the output of the swap, right? So this router automatically sort of like finds all the most efficient routes, 5 over 50 trade paths, right, across various AMMs, across various pools within the AMMs to find like the most efficient routing. So that's why that is something which is pretty awesome, because at the end of the day, the user doesn't know, doesn't have to deal with, you know, how this works, right? All he has to know is that he's going to get the best price across all the liquidity that we have, right? And that means, you know, $1 of DOT, you know, is going to get him the most efficient pricing there is, right? And that's basically the purpose of our router, which is to unify the liquidity across the board, across our AMM. So this is basically how the structure, right, and how the order execution happens. You know, from a user point of view, whenever they sort of like go to StellaSwap, app.stellaswap.com, you know, they can choose whatever tokens that they want to trade on, right? So when they press the swap button after they've sort of like identified the input and output, what they do is that they have to approve the token first. We've actually integrated permit 2, which is done by Uniswap, right? And the reason that is token, as in one-time token approval, which is very secure, and it actually improves the UX because there's like the gasless component of it, you know. So we've actually integrated permit 2 to sort of like make the whole infra more secure as well as more UX friendly. So what happens is that when a user sort of like puts in the input and outputs, and we need the signature hash from the permit tool, combined with the routing API, which is predicated on the user's input, right, and output token. What happens is that the call data gets sent to the router smart contract, right? And the router smart contract actually sorts of like executes the order across different AMMs, whether it be V3, pulsar, concentrated liquidity, stable AMM, or normal AMM. So yeah, that is and then at the end of the day, once this is done, it's gonna be executed. Right. So if we have a look at how the trade happens, right? You go to Stella. You go to our platform, and you click a trade, right? And then you try to get something. What do you call it? Dot. Right. For example, USDC dot, and then you click the input, how much USDC that you want to convert into dot, and this is when the trade router is doing its computation, right? And you can see that this is where you manifest the trade routing is manifested, right? You can see that from your input to your output, it goes along two pools within the V3, which is the concentrated liquidity. USDC to Glimmer, Glimmer to dot, Glimmer to D2O, which is a stable coin, and D2O to dot, which goes, 3 pools, so 3 hops within that. So this is the most efficient way to get USDC to dot based on all the liquidity and various AMM pools that we have. So that is where the trade router does its work and displays and manifests the most efficient trade routing. And then this is where the approval function that when a user clicks as part of the permit tool, right, is here, right, where they have to approve this, and yeah, and this is our sort of like on Moonbeam EVM. This is where the permit to contract is. All right, the permit to. So once the user approves the USDC, then we can put it all to action and yeah, start and generate the output for the user. So basically, that's how. That's how we sort of unify the entire sort of like the liquidity across all the AMMs. All right. So yeah, this is like permit 2. A bit more about permit 2. So it's non-upgradable, unowned, and open source. It was created by Uniswap back in 2022, mid 2022, right? It allows for one-time token approval. Actually, it could also be token as in time limited token approval. So you can set it anytime that you want, and it can be interchangeable with any dApp. So if you have actually gotten your token approval on Stellar and you want to go to any other dApp, within the ecosystem that uses permit to, it's interchangeable, so you don't have to do it again. Right, and gasless swaps, that's one of the sort of a value proposition of using permit to, and obviously enhances the user experience. So this is where the trade execution happens when a user inputs what token they want, what token they're using, the amount, and whatever slippage tolerance that they prefer. This is all going to be bundled up into call data here, which not only sort of like captures all the commands, but actually captures the sequence of the commands, right? And then once all these commands are sort of like uh, captured by the smart contract, it's then going to be executed based on the routing instructions, right? So that is basically the first thing agenda, which is how we built our own trade router to unify liquidity across all the AMMs. We were the first to do that, right? And yeah, that is something which remains one of the core infra that we've built with regards to making swaps more efficient and tapping on the liquidity depth of each pool across each AMM. So the second thing which we recently launched like 2-3 months ago was an LSD, SD dot, which if you're familiar with Lido, right, what happened was that they sunsetted the SD dot, which had a lot of promise and TVL. And what we sort of like talked to the Lido team, right? And we sort of like said, understood their challenges and felt that this was something that needed continuity, and that's why we sort of like took over the SD dot project from Lido. And basically, this is how, this is how it works on the back end, right? Sorry, on an overview level, we have like almost 3 million in TVL right now, and LSDs are a crucial part of the DeFi ecosystem because it facilitates a use case, a very interesting use case that fosters great composability for POS networks, right? When you stake your tokens for collateral rewards, but it is stuck, right? So what LSDs does is to sort of like supercharge that previously stuck tokens so that you can use in DeFi. So that's why they play a very crucial role in DeFi in terms of utility. So you can earn collateral rewards with SD dot, and then since we're a DEX, we list the SD dot as farms, SD dot, SD dot glimmer. You can earn further rewards on that, and also opening up the utility for lending and borrowing, like on Moonwell on Prime protocol soon, right? So a lot of interesting stuff happening to supercharge or fuel the growth of LSD dot on on Polkadot. Interestingly enough, we have launched all 3 top LSD dot under the dot campaign last 2 months, and so far those LSD dots have had the highest TVL growth, right? So how does liquid staking our SD dot work? Since we're on Moonbeam, right? Moonbeam is EVM and Polkadot is basically substrate, all right? So you can see like a clear division between the technical architecture, which on the Moonbeam end as well as the Polkadot end, you can see that on the ST, once a user, the main function of a user addressing as in using ST dot would be to stake or unstake. That's the 2 main functions, right? So what happens when that function is called is there are ledgers, right? All these ledgers are basically like bookkeeping, like literally ledgers, right? Which are accounts by which we track the ST dot balances. Now, why do we need a few ledgers? Why not only one ledger? Because for dot staking on Polkadot, there is a limitation of 32 sort of like withdrawal calls, right? So, so imagine a person that has staked 32 times, all right? 40 times, and he wants to withdraw everything at once. We can't actually do that because there's a max of 32 withdrawals that we can process. So that's why we need to have a few ledger accounts, to mitigate against that function. Now, what's interesting is that for our ledger infra, we actually have a queuing system, all right? So every era, which is 24 hours in Polkadot, every 24 hours, we will batch in all withdrawals and deposits, right, at the ledger, and then we will sort of like combine and aggregate them. After the 24th hour, we are going to push it to the derivative accounts and stake or unstake. So what this allows is that the batching from the queuing system, right, allows us to sort of like mitigate against the limitation of the ledger derivative accounts having a max 32 call unstaking. So I mean that's one of the mitigating, and what from a front user perspective, it's very convenient, right? Because imagine if within the era 24 hours there's like 100 dot that is deposited and 80 dot which users want to withdraw. So what happens at the aggregated ledger level is where the users, instead of waiting 28 days and going through the entire process, we can settle his balance here and he can get his dot immediately. So that's one of the cool stuff that we have in terms of our unstaking, staking and unstaking. The queuing system to facilitate quick deposits, quick withdrawals whenever users want. As in, but the condition must be that there must be sufficient deposit to meet the withdrawal obligations. So, going back to sort of like this ledger system, right? Since we're on Moonbeam, so we have sort of like Moonbeam has their own sovereign account, right, on Polkadot, and the controller account is basically a child account of the Moonbeam sovereign account, right? And therefore that will allow us. The main function of the controller is actually to execute, right? To send XCM transfers execution for both staking and unstaking, so that they can send basically XCM transfers and transactions are executed at the controller level, which is a child of the Moonbeam sovereign account. And over here at the substrate end, their derivative accounts are like sort of like parallels on the ledger account, right? And basically, this is the derivative accounts are basically the child of the controller account. So there's a unified sort of like a ledger, what you call that, accounting controls there, so that we are, from the controller end, when it pushes the XCM, sort of like messaging through, and then all the balances and all the functions, all the calls, are sort of derived on the derivative accounts, and then it's gonna sort of like stake or unstake depending on what message from the controller. So that's how, on a high level, the liquid staking works on ST dot. It is pretty sort of like quite a complex affair, because there is a lot of basically there's a lot of technicalities involved with regards to liquid staking, and this took us like 6 months to deploy, even with Lido's code, right? So because we needed to make sure that everything was perfect, and that the whatever runtimes regarding the XCM is is tested before we deploy, because just a few weeks ago there when they deployed the XCM runtime with regards to XCM fees, that was something that sort of like changed, affected how the flow works. So that is something that we had to improvise. But yeah, as in, this was something that took a lot of time, and is a very important sort of like product for us as well. Right, so yeah, this is basically on a high level derivative accounts. Derived from the sovereign account, having their own certain index, like ours is like index 5. So from Moonbeam sovereign account, this is our controller account, and this is basically the derivative accounts, right? Which is all derived from each other. So yeah, that's. And the last thing, I have like 5 minutes left. that is actually extremely interesting because we are removing the need for farming. So, I mean, traditionally in DeFi, you need to stake your LP to get the farm rewards, right? But we're actually removing that with the, because we're building our own like off-chain or Merkle rewarder. And the reason behind that is pretty simple, actually. Farming on DeFi usually requires an LP token or NFTs. They're rewarded based on their tokens locked, several other conditions, right? Whether their liquidity is in range, in the context of concentrated liquidity, you know, and then this creates a single point of failure, right? The rewarder contract, which is in charge of giving out the rewards, and also as in what's not captured here is that one of the main sort of like reasons for us to do our own solution is because the current way of concentrated liquidity or V3 farming is pretty inefficient because there's a lot of dependencies on active liquidity managers like Gamma, like Arrakis. Previously, before V3, if you remember, beefy, automated and reinvested LP staking rewards, right? That's a very easy thing to use, right? And they're merely a service provider that users can tap on automated staking, But with V3, the issue is that you have to depend on ALMs for automated V3 staking so that you don't go out of range. And the issue with that is that you have to set up a separate economic pool over the ALMs. So what this entailed is, imagine if you have 3 ALMs, right? Gamma, Arrakis, Steer protocol, Each of the ALM you have to have you have to manage your rewards, for that one single farm across 3 ALMs, which is totally inefficient and, the potential of failure as well, which Gamma had an exploit. So we were thinking to ourselves, no, this is too convoluted. We had to create our own off-chain rewarder, right? So that we can unify. So the ALMs, we reduce the dependencies on ALMs, right? The rewarder will be on our end. So whatever ALMs that support us, users will still get rewards, but the rewards will be on our end. It's centrally sort of like located so that everything flows through all the liquidity providers without needing to set up accounts in each ALMs and do, and cumbersomely, as in calculate rewards, all that. So the solution was this, right? Create off-chain rewarding based on index data, calculate Merkle tree proofs, and root hash, update the root hash on the smart contract, much more efficient way, and then therefore users can claim their rewards. So this is basically how it worked. Users go to a DEX, they provide liquidity, right? Or even an ALM, right? And at this level, the indexing level, where all the data regarding the user's positions, either directly from our DEX or from an ALM, like Gamma, as a Gamma Arrakis, right? All this is indexed using our on-chain data providers like sub0 or the Graph. And we can then, based on the on-chain data, identifying users' positions and characteristics and conditions, we can actually calculate the rewards, right, based on the liquidity provided, right? And then that is going to be sort of like stored and verified within the sort of like the Merkle tree. It's going to be updated. What we need is basically whenever a user wants to claim, we just need the hash generated from their input or the address, and then on the rewarder smart contracts, it will call the whatever that is due to the user. So that is something which is that will really simplify the V3 staking, because right now V3 is the most dominant form of liquidity staking on not only StellaSwap but across DeFi. So this is the infrastructure. This is the long-term infrastructure that we're building. They're even beefy. They were like, you guys are building your own Merkle tree rewarder. That is cool because that is something that can be sort of like outsourced or used by any other projects down the line. So yeah, this is something that we're focused on. Taken us like 6 months also to and still not completed yet. It's another month of testing before we deploy this, and yeah, hopefully we can deploy it soon, and then we can really simplify staking. So yeah, if there's any questions, feel free to ask, or you can reach out to me on StellaSwap, and then we can sort of like answer any questions. Appreciate your time.